My name is Magdalena. I'm from English major. Right now I'm going to reading topic about life on Mars. Life on Mars. A new study published in the journal Science show definite evidence of organic matter on the surface of Mars. The data was collected by NASA nuclear power rover Curiosity. It confirmed earlier findings that the red planet was containing carbon-based compounds. These compounds, also called organic molecules, are essential ingredients for life as scientists understand. The organic molecules were found in Mars Gala crater, a large area that may have been a watery lake over 3 billion years ago. The rover encountered traces of the molecule in rock. The rover encountered traces of the molecule in rock extracted from the area. The rock also contained sulfur, which scientists speculate helped preserve the organic even when the rock were exposed to the harsh radiation on the surface of the planet. Scientists are quick to state that the presence of these organic molecules is not sufficient evidence for ancient life on Mars, as the molecules could have been formed by non-living processes, but is still one of the most astonishing discoveries, which could leave the future revelations, especially when one considers the other stalling find the Curiosity uncovered around 5 years ago. For analyzes the air around it periodically, and in 2014 it found the air contained another of the most basic organic molecules and a key ingredient of natural gas, methane. One of the characteristics of methane is that it only survives a few hundred years. This means that something somewhere on Mars is replenishing the supply. According to NASA, Mars emits thousands of tons of methane at a time. The level of methane rises and falls at seasonal intervals in the years, almost as if the planet is breathing it. NASA suspects the methane comes from deep under the surface on the planet. The variation in temperature in the surface on the methane comes from deep under the surface of the planet. The variation in example, in the Martian winter the gas could get trapped in underground icy crystals. These crystals, called clathrates, melt in the summer and release the gas. However, the source of the methane is still a complete mystery. Of astrobiology, consider both of these studies as historical milestones. According to these informations, Mars is not a dead planet. One of contrary is it is quite active and may be changing and becoming more habitable. Of course, this means further research is necessary. Scientists say they need to send new equipment to Mars, equipment that can measure the air and soil with more precision. There are already missions underway. The European Space Agency's ExoMars ship lands in 2020 and will be able to drill into the ground on Mars to analyze what it finds. Additionally, NASA is sending another Mars rover in the same years to collect samples of Martian soil and return them to Earth. The possibility of life on Mars has fascinated humans for generations. It has been the subject of endless science fiction novels and films. Are we alone in the universe, or have there been other life forms within our solar system? If the current missions to the red planet continue, it looks as if we might discover an answer very soon. How humans evolve language. Thanks to field in linguistics, we know much about the development of the 5,000 plus languages in existence today. We can describe their grammar and pronunciation and see how their spoken and written form have changed over time. For example, we understand the origin of the Indo-European group of languages, which include Norwegian, Hindi, and English, and can trace them back to tribes in Eastern Europe in about 3000 BC. Experts are beginning to look to the field of evolutionary to find out how the human species developed to be able to use language. So far, there are far more questions and half theories than answers. We know the human language is far more complex than that of even ordinary and most intelligent relatives like chimpanzees. We can express complex thoughts, convey subtle emotion, and communicate about abstract concepts such as past and future. And we do this following a set of structural rules, known as grammar. Do only humans use an innate system of rules to govern the order of words? Perhaps not, as some research might suggest dolphins share this capability because they are able to recognize when these rules are broken. If we want to know where our capability for complex language came from, we need to look at how our brains are different for other animals. This relates to more than just brain size. It is important what other things our brains can do and when and why they evolve the way. And for this there are very few cycle clues. Artifacts left by our ancestors don't tell us what species they were capable of making. One thing we can see in the remains of early humans, however, is the development of the mouth, throat, and tongue. By about 100,000 years ago, humans had evolved the ability to create complex sounds. Before that, evolutionary biologists can only guess whether or not early humans communicate using more basic sounds. Another question is, what is it about human brains that allow language to evolve in a way that it did not in other primates? At some point, our brains become able to make our mouths produce vowel and consonant sounds, and we develop the capacity to invent words that name things around us. The next thing would have been to put this word into sentences, similar to the proto-language children use when they first learn to speak. No one knows if the next step, adding grammar to signal past, present, and future, for example, or plural and relative clauses, require a further development in the human brain or was simply a response to our increasingly civilized way of living together. Between 10,000 and 50,000 years ago, that we start to see the evidence of early human civilization. Through cave paintings, for example, no one knows the connection between this and language. Brain didn't suddenly get bigger, yet human did become more complex and more intelligent. Was it using language and caused their brain to develop? Or did their more complex brains start producing language? More questions lie in looking at the influence of genetics on brain and language development. Are these genes the mutated and gift of language ability? Researchers have found a gene mutation and occur between 200,000 and 100,000 years ago, which seem to have a connection with speaking and how our brain controls our mood and face. Monkeys have a similar gene, but it did not undergo this mutation. It's too early to say how much influence genes have a language, but one day the answer might be found in our DNA. That's all for me. See you next time. Bye.